Hi, I'm Steve Endo, and I'm a Microsoft MVP. Today I asked the question, is it possible to create a zero-code Microsoft Flow web service API? Let's get started. So here's the challenge. A small business customer with no internal development staff that uses an on-premises ERP system with no existing integration infrastructure needs to receive shipment data from their 3PL warehouses. And that 3PL warehouse company has asked to call a web service in order to send the customer shipment information. So every time a shipment goes out, they want to send the order information, the items that were shipped, and tracking information. So how can we solve that problem? So what are our traditional web service options for this scenario? The customer could try to use their native on-prem ERP web service. It does exist, however, it's difficult to set up, it has limited and fixed endpoints and methods that can be called, and it is moderately complex to use. It's an older SOAP-based web service, and it requires multiple calls in order to perform one operation. It's not quite as easy as what we're used to now with RESTful web services that can often have one call that does everything we need. We could potentially design and develop a custom web service. That's always an option, but there's a developer required for that process. And when you develop your own web service, you've got to deal with the infrastructure. You've got to build your own overhead like logging, authentication, security, things like that. So overall, that process can be a little more expensive and complex than what a small business customer or medium business might be interested in. Now, what's really appealing is something like Azure Functions. Those are serverless functions that you can host on the Azure platform with very minimal effort. However, those do require a developer. You need Visual Studio or similar development tool, and you need to develop something that can be uploaded to the Azure Functions platform in order to run. But that is a very appealing option that would work. But is there a better option? Well, what about Microsoft Flow? And you may say, Flow? Why would I use Microsoft Flow to build a web service API? Well, it turns out that Microsoft Flow has an HTTP endpoint trigger, and that's effectively a web service. It includes automatic JSON parsing. So you can receive a JSON payload, you can parse it, you can pull out the elements you need, and you can perform operations on those elements. And of course, Microsoft Flow has a SQL Server connector. So you can connect to an on-premises SQL Server instance, you can connect to an Azure SQL database, you can connect to an Azure SQL instance, or you could connect to a fully hosted SQL Server VM running in Azure. So you have lots of connectivity options there. And so all of these pieces made me ask, well, could I build a custom web service API using Microsoft Flow? Let's give that a try. So here I have a sample of the JSON payload that the 3PL wants to send us. So here we have an order number, customer ID, we see the line items that were shipped with quantities, and we also have tracking numbers. And this is just mocked up data. You'll notice it is relatively simple for a JSON payload. A lot of real-world JSON payloads are much more complex than this, which I'll discuss later. But for purposes of this demonstration, I thought this was a fairly good example of a simple payload that a 3PL might be sending you when it ships orders. So now that we've seen our JSON payload, let's create a new Microsoft Flow. I'm going to create from blank, and this part may be a little confusing. If you search for HTTP, looking for an HTTP request, you may think you want to choose these, but it's actually under the request type. So under your connector type, you'll choose request, and we'll choose this one, request when an HTTP request is received. So you'll select that. And you'll notice here the note that the post URL will be generated after save. Great. So how do I receive a JSON payload with Flow? And it says, well, you need to paste in your request body JSON schema. Well, what if I don't know how to do that? Well, fortunately, they have that handled for you. It says you can use your sample payload to generate the schema. Excellent. You click on that, and I can copy my sample payload. I'm going to paste it in. And that quickly, it scans the payload and automatically builds your JSON schema for you. And there is a note here that remember to include a content type header of application JSON in your request, and that'll be important later on. Great. So now you see we have our JSON schema built for us. It scanned the JSON, found where we have arrays, it found the field names. Perfect. So now that we have our HTTP request action set up, let's add the next step, which is to insert our data into SQL Server. So I'm going to type SQL here, and we're going to choose SQL Server, and I'm going to insert row. Now, I already have set up a SQL Azure database with 3 tables, and the tables that I'm interested today are shipments and tracking numbers. So over here, the items that were shipped, those are my shipments, and the tracking numbers down below, those will go into my tracking numbers. Let's start with shipments. I'm going to choose my CSTV shipments table, and you'll notice that it automatically identifies the fields in that table. All I need to do is click on each field, and Microsoft Flow has already identified the fields that are coming from my JSON payload. Fantastic. I want to put my order number in there. I'm going to put my customer ID there, my item number. I click, and my quantity shipped, and let me just make this bigger, and I'm going to see more, and there's my quantity shipped field. So with just a few clicks, I've created an HTTP endpoint, and I've told it that I want to take my item shipped and insert it into this table, and with a few clicks I've mapped my fields. Now you'll notice one thing it did is added an apply to each. It knows that item shipped can be an array, so it's automatically detected that. It said, okay, great. If you get multiple item shipments, I'm going to loop through them and insert them into your database, multiple records. Fantastic. So that's great, but then how do I handle my tracking numbers? Well, there are a few ways to do this. One way is to add a parallel branch. So in addition to importing items shipped, I'm going to add a parallel branch that simultaneously inserts tracking numbers. So I'm going to add that branch in here, and similar to the item shipped, I'm going to do SQL Server, insert row, choose my table of tracking numbers, and similarly we have our list of fields. Let me make this bigger. We have our order number, customer ID, we have our carrier, and last we have our tracking number. So with just a few clicks, I'm now inserting my item shipped into my SQL Server database table. I'm inserting my tracking numbers into the tracking number table, and we are set. So let's save this. And now that we've saved it, let's take a look at our HTTP request. You see that we now have our own HTTP post URL. So Microsoft Flow, just by creating this HTTP endpoint, has given us our very own URL. We can now copy that. And now that we've copied it, let's do a test. Let's go over to Postman, create a new tab, set it to post. Let's paste in the URL from our flow. And you'll notice in the body, I've selected raw content, application/JSON content type, and I pasted in my payload. Click on the send button. And 1.2 seconds later, we have a 202 accepted. Let's hop over to SQL Server Management Studio and query our tables. Here you see that we have data already inserted in. We have 10 records for our shipped items, and we have 10 tracking numbers for our shipments. So that quickly, in just a few minutes, we've created a custom web service API that can accept a JSON payload and insert it into SQL Server tables. Okay, well, let's get a little fancier. You'll notice that in our Postman, we only have a status of 202 accepted. And that doesn't tell us that that was necessarily successful. It just says, okay, we've accepted your request and we're going to try to process it. Let's get a little fancier here and add a response. So back in our flow, we're going to add a new step that will allow us to return our own response code when the flow is complete. So we'll add an action here. And the action is actually under the request type, but you can search for request or response. If we go down here, you see request-response. And this gives us the ability to return our own status code, whether it's success or failure. We can handle errors, and we can have our own body response here. So I'm going to return shipment information saved. I'll click on Save. Okay, so now our flow is going to run, it's going to save our records, and we're going to return a response code. Let's give that a try. Let's clear out the records here. And let's click Send again. Now you'll notice something a little different. Before we had a response relatively quickly because flow is simply returning a generic response indicating that the request was accepted. Now we are getting a 200 OK and we are getting our custom response, but notice how long it takes. It's taking generally anywhere from 8 to 10 seconds to save those 10 records in parallel. So we have 10 shipment records, we have 10 tracking number records, and in my testing, the average time was about 1 second per record that's inserted into SQL. So in this case, we're inserting 20 records, but we're doing 10 and 10 in parallel, so our response time is around 10 seconds. Now, how can we improve that? Well, with the help of some feedback I received on Twitter, we can go to our Apply to Each steps here, go into Settings, and we can override that default value, and we can increase this to allow it to spawn more threads. And so somewhere in the 20 to 30 range appears to produce some improvement in this case. So we will override the default and up that to 30. And then let's save our flow here. So now let's go back to Postman and try one more time. So our prior time was 8.1 seconds. And you notice it was a significant improvement making that concurrency change down to under 2 seconds. So that's a pretty dramatic improvement. And so if you're doing large payloads, a lot of processing, a lot of SQL inserts, that option is pretty critical to improve the concurrency of your flow operations to improve performance and response time. So this is a tolerable response time. It's not fantastic, but it's acceptable. So you notice that the time varies a little bit. So 1.8 seconds, 2.6 seconds. So you have to be able to tolerate some variability in the responses. Here we got up to 3 seconds. So it's not super consistent, but it's a big improvement from 8 to 10 seconds. And of course, we can verify that everything was inserted by querying our tables. And we are seeing 40 rows and 40 rows inserted. So our data is getting inserted, but when we use flow as the endpoint, we will have some variability of time and won't be the greatest performance, but we were able to create this custom web service API in just a couple minutes with just clicking 0 code. Now, this response is always returning successful. You can add try-catch steps in your flow in order to handle errors. So if an error is detected, you can have a catch block that returns an error code and lets the caller know that that save failed. And then if everything went well, you can return a successful response code. So that is definitely possible with Flow. You can get some pretty nice error handling, probably not as advanced as something like an Azure function or a custom web service, but for just a few clicks, it's hard to beat. Now, just for a comparison on the performance side, I've created an equivalent Azure function that can receive the exact same payload. And so I was testing the Azure Functions performance writing to the same SQL Server or Azure SQL database instance. And so let's clear out our data. So now we have empty tables, and this is a test of the Azure function. And this Azure function performs the exact same saves to both tables, but it does it all sequentially. And in this case, the code returns how long it took. So that first run took about 1 second, but you notice the total response time for the Azure function to spool up was about 6.2 seconds. Now, if we try that again, we should get better performance. And there you see, now that the Azure function is up and running, we're under 1 second, 744 milliseconds total response time, and the actual save to the SQL database was 667 milliseconds. So for larger, more complex payloads, higher processing requirements, you may need to go to Azure Function, but that requires some code. It's pretty hard to beat Microsoft Flow with a few clicks. So if you can tolerate a couple second response time, that's not bad. And I suspect many web service calls can handle a 3-second response time. And so here we see our data is getting inserted. So it's working great. So that's an overview of how you can very quickly set up a Microsoft Flow for a custom web service API with just a few clicks. So what did we just see? Very cool process where you can have a zero code, literally not a single line of code, custom web microservice API in minutes. Now, I call it a microservice because it only does one thing. It's one endpoint that handles one payload, and it does that one thing very simply but very well. And it required no code. Any user could do it in theory by just clicking on fields. And I think it's a very interesting option for budget-conscious or non-technical customers. It's also a great option to prototype. Instead of having to write code to prototype an API, if you have a situation where it would work, you could potentially spool up a Flow custom web service in minutes to prototype a process. So that's very cool. So of course, with that convenience, you get some caveats. First of all, the Microsoft Flow web service endpoint is JSON only. If you have to receive an XML endpoint, my understanding is at this time that is not currently supported. So you have to have a JSON payload. Second, there are some limitations with complex JSON payloads and highly variable JSON structures. The example payload that I created was relatively simple. In the real world, you'll often get much more complex payloads. And one of the big problems with those complex JSON payloads is that they may be highly variable. So for instance, when it's called under a certain circumstance, you may receive a payload with an array. And under another circumstance, that same payload may not have that same array. It may have a null value or it may skip that node entirely. And based on my tests, Flow does not like those types of payloads. So 1 minute there's an array, the next time there is an array, it does not like that. And as you saw, the calls to the Microsoft SQL Server instance were relatively slow. On average, it looks like it's about 1 second per insert when you're running with a single Flow instance. So if you're inserting 10 records, that could take up to 10 seconds. Now, as you saw, we can increase the concurrency to have it spawn new threads to perform those inserts in parallel. So if you're inserting 100 records in theory, you could scale out to get 100 instances and get down to somewhere around 1 second for all those inserts. However, you also saw that that time was highly variable. Sometimes you may get 1 second, other times you may get 3 or 4 seconds. So that operation is relatively slow in Flow. And I mentioned the highly variable response time. If the calling party can handle that high response time variation, then you might be okay. But if you need very consistent sub-second response times, this may not be the best solution for you. Because of that variability and less than optimal performance in some circumstances, this may not be ideal for highly synchronous integration. So if someone's making a live e-commerce order integration, this may not be the best option for that because you don't want a customer waiting for a response when they're placing that order. And you may find some error handling limitations. There are options for error handling in Flow, but depending on how complex you need that error handling, validation, branching, things like that, you may find that it's easier to do in Visual Studio, in Azure Functions, in a traditional web service. So that's something to consider. And security. Some customers may not be comfortable with just URL authentication for their web service endpoint, and they may want additional authentication and authorization code in their web services. Totally understandable, but that takes time, that takes coding, that takes more complexity, whereas this is very simple. You're up and running in minutes, so it's all a trade-off. Now that we've seen what Microsoft Flow can do and how quickly you can set up a very functional and capable web service, what are some other ideas for how you could use this? Let's say you have an e-commerce website or a subscription website where new customers are registering their information. You could easily push that new customer information via a Flow web service. If you needed to expose current inventory status and quantities to an e-commerce system, you could very easily do that. Set up a Flow endpoint that does a query against your SQL tables and returns those inventory quantities. You could check order status when a customer logs on and looks at an order status. That's not quite as critical or time sensitive, so if that takes 1 or 2 seconds to pull, that would work great. Or for other scenarios, let's say that you have remote field technicians and you want an easy way to receive updates from them that involves web services. You could have a Flow web service that can receive those updates via the HTTP request endpoint. Perhaps you have IoT devices out in the field. You could use Flow web service endpoints for IoT data collection or telemetry. And as I mentioned, you can quickly prototype and test web services with absolutely zero code. If you have a simple JSON payload you can work with, in less than 5 minutes, you'll be up and running with a web service endpoint. So that's a very, very valuable thing to have. Well, I hope you found this interesting and helpful. Go ahead and follow me on Twitter at SteveEndo, or check out my blog at steveendo.com or dynamicsgplan.blogspot.com.